Hi again, everybody. Today, I'm going to go over something that's very popular and the foundation and the basics. And I found a better schematic or a tutorial, very simplified. I think that will give more meaning and more analysis and better understanding of what fuel injection system is. And basically, this is the rule for all fuel injection systems. As you know, we need spark. Well, and we have a computer. So the layout that I found, the schematic that I found, I think will be very beneficial to the viewers to give a rough estimate of what's going on. As you know, I've been doing previous videos and they are very technical, but this is more simplified. So let's start from the basics. We have ignition coil, distributor. This is the ignition control module, so to say. And we have a PCM, a computer. In the computer, there are various components and other modules, and they need inputs. Those inputs are from the sensors. As you can see, all these sensors coming in. Volume of air, the temperature of the air, barometric pressure, the throttle position sensor tells it also, the coolant temperature, how hot the engine is, how cold the engine is, crankshaft and camshaft sensors, how much the crankshaft is turning, the camshaft is turning, which are parts of the engine, obviously. These are all inputs, as I've told you in my other videos. The output is a control signal that goes to, this is called a transistor. 3 elements, which I made many videos about. This is the base, this is the collector, this is the emitter. In order to turn on this transistor, we need a control signal to go to this base. This will turn on the transistor. Now, a coil or a transformer has a primary, and a coil has many turns on it. But the secondary has much more turns on it. So this can have 100, this can have 10,000. The more turns, the higher the voltage. And that's the idea of it. So we're using this control signal based upon all the inputs that's going into this computer to tell it how the engine is going now, how much air, how much fuel to put in, how much spark in this instant, how much spark we need, when to turn on the spark on and off. And this is why we need the inputs. So therefore, the control signal goes to this transistor. This will be like a switch, acting like a switch going to ground. And it has to be either turned on or turned off. When this is turned on, we have a B+ ignition switch, which is the fuse. We have current coming here, flowing in here, through this primary, through this coil. This creates a magnetic field around it. Now, in order to get a magnetic field around this, which is higher voltage, to get a spark, we do this method. The ECM, which is the computer module, or the PCM, like I refer to in Chevys and other videos, same idea, same computer module. The control signal will turn off the transistor. When you turn off this transistor, or a switch, like we want to call it, current cannot flow. But this will, the magnitude and the magnetic field in it will grow to a certain limited amount. The magnetic field. So therefore, the current goes in it, flows through this, and now it's cut off. Boom. So now there's no transistor, no switch to ground. This magnetic field collapses. When it collapses, it induces another secondary magnetic field or voltage, like a transformer, induces a voltage into the secondary. So in other words, when the computer sees that needs spark, send a control signal to this transistor or a switch, turn it off, current is cut off, creates the magnetic field that is saturated, and the voltage is now induced into the secondary. This is around the magnetic core. It's wound around the magnetic core internally. And therefore, the lines, the voltage goes from primary to secondary. That's how a transformer works. Ignition coil, they call it. Again, this is cut off. the magnetic field collapses. When it collapses, boom, that's when you get the voltage. You got it. Going to the distributor. Distributor turns, revolves to give the spark to each cylinder. In this, you see 1, 2, 3, 4. This means this is a 4-cylinder engine. And that's basically how spark works. We always have a transistor going to ground, but we don't see it in the schematics. Every time I talk about a PCM or things like that, they always refer to it as ground. But this is what's going on internally. In the ignition control module, there's a transistor, and the PCM is giving the control signal. And this one talks to the other. And this is exactly how I can analyze it and simplify it as best as I can to try to teach people what's going on when I tell you ignition control module. This is what's happening. Again, when this is turned on, current flows. The magnetic field is induced to a certain degree, and it gets saturated. When this is turned off, it collapses, and then you get, boom, you get a secondary voltage to create the spark to go through each cylinder. There's a capacitor over here. The capacitor is charged from the B+, the battery, and it holds the charge until it discharges. And if you ever saw, sometimes you have the battery, when you shut off the car, the engine, then you see the radio still running and things like that. Well, that's because there's a capacitor holding the charge, and it discharges. The time that it takes it to discharge is the time that it'll be on your accessories or the radio until it's fully discharged. So therefore, I'm glad that I found this. I think this is very helpful and very informative to my viewers. And again, subscribe to my channel. I'm so thankful for all the views that I've been getting the last 2 weeks. Like I said so many times, I'm so grateful and appreciative of the viewers that I have these couple of weeks. Really, it's been really getting increasing. And like I said, I want to continue doing the job and increasing and improving the quality of each video as much as I can. So I need everybody's feedback from comments, and they're more than welcome. And negative comments are always welcome, so I can improve the quality of my videos, so I can teach people the skill, and hopefully it would help them. Thanks for watching.